vertical circles. So, I think I forgot to do something in the previous slide. Alright, I'm going to do it here. So, you know that force, okay. You know that force is mass times acceleration, right? Centripetal acceleration, you knew to be v squared over r. So for centripetal force, it would be m v squared over r, where Fc is the sum of all forces that are aiding in the centripetal motion. We can rewrite this by saying Fc, or centripetal force, divided by mass equals the centripetal acceleration. And this is easier, in my opinion, to use, while this setup is easier, in my opinion, while solving centripetal forces, or doing anything related to centripetal forces. I think this is pretty neat. Okay, so let's say we have a car, right? It's at the top, it's going, it's right there, and if it were to continue its path up this huge speed breaker, it would go in a circular motion that way. But it doesn't. It goes off this way, into this path, if it extended. So you are asked to find how you are asked to find what do I say? Alright, you're asked to find normal force that this car has as it's passing through the top of this circle, or semicircular speed breaker. So you know that that's the center, right? And that's the radius. And whatever is gonna keep this car grounded to this speed breaker and not just let it go off or fly off to the right is going to be the centripetal force. So whatever is going to keep it in this path, along this semicircular path, is going to be the centripetal force. In our case, centripetal force here is going to be mg, or weight force. That weight force, or gravity, or force of gravity, or whatever you want to call it, same thing. That is going to be our centripetal force here. So when we set it up, F's sum of all forces to cause the centripetal force divided by mass equals v squared over r. That's the sum. Don't forget that. This is key in the setup. That will help you a lot. And there's a normal force here, and it's pointing this way. Normal force. I'm gonna write it this way. That normal force, it's pointing that way. So how do I do this? You're asked to find the force normal. So mg, pointing towards the center of the circle, would be the positive quantity here. And force normal, which is pointing away from the center, would be the negative quantity. So when you put it in this formula, you would say mg minus Fn over m equals v squared over r. that would be the forces. And from here, you're going to solve for Fn, or you're going to isolate Fn to get your force normal. And that's going to be your answer. So let's do that. Fn equals, you bring m to the other side, so it would be mv squared over r, it's not, well, yeah, r, and then when you bring that over, this just becomes mg minus Fn, then you bring mg over to the other side, and this becomes negative mg, but there's still a negative here. So you divide that out from this side, so this becomes positive Fn, and here it becomes negative mv squared over r plus mg. And that's how you get Fn from this car. And that's just the introductory lesson for vertical circles. So let's try adding some numbers into this and try doing it again. So I'm gonna use a different color, something bright. Okay. Erase a few things. Okay. I'll use blue. I never use blue. Okay. So let's say that the mass of this car is 100, right? The mass of this car is 100 kilograms. Okay. Kilograms. Why is this? Oh, I'm in highlighter. Okay. Yeah, it doesn't matter. No, it doesn't matter. 100 kilograms. That's your mass. Yeah, that's bugging me. Alright, I'll put orange. Alright, that's 100 kilograms. Alright. And let's say the radius is 8 meters. So, do the same thing. We found Fn to be negative mv squared over r plus mg. So let's do that. Fn is negative 100. Oh, I didn't say velocity. Okay, let's say this was 4 meters per second. 4 meters per second. 4 square over 8. I've reached the end. Alright, by over 8 plus 100 times 10, because that's 100 and g is 10, so that's 1,000 plus 1,000. Sorry. Okay, plus 1,000. Trying my best to make that look like 1,000. So when you solve it all out, what do you get? That's your force normal. I don't have the time to solve all that, so I'll leave that here.